Most of the time, we're just the fan spinning up on this thing.
It can start faster than the fan sometimes. And it's not just reserved, like UEFI performance isn't just for big, crazy, powerful systems. This is the PC that you blogged about in the boot performance blog. And you know, when you see it start up, you see that you don't have like BIOS screens flashing like DOS characters and stuff. 8 seconds. This is an in-market, shipping today PC.
This is a Windows 7 PC.
It's a Windows 7 PC in market today, but UEFI is really important because it's not just about speed and having a boot that looks better, it's about security too. So I'm gonna boot this PC, except I'm gonna do it from this infected USB key. This has got a rootkit virus on it, which is a really nasty piece of malware because you boot from it and your machine would be owned before any software-based security could possibly keep up, but not with UEFI. I'm gonna put it in here. Say boot from USB, and you can see it booting. Probably see it flashing. Boom. Boom. That's it. Invalid signature. And so what happened was UEFI checked the boot volume. It had been compromised. And now I'm going to turn this off and turn it back on, and it'll be right back to normal. This is just one of the security features that we have in the product.
Yeah, there's tons of security features. Like if this machine also had been using BitLocker, then you can't even rip the drive out and use it in other places. So a full range of security software. In fact, one of the things that we've got in Windows 8 is we've taken Defender and we've actually built a whole new range of protection all the way up through anti-malware, antivirus. All of that is built into Defender should you want to choose to use it, or you could use your own security software. But when I showed you that working set earlier, that 281 meg, antivirus is running in there as well.
And this is actually an encrypted drive while it's running, so the security's everywhere. So it's good stuff because all Windows 8 PCs will be faster and more secure as a result. And there's a whole new class of Windows 8 PCs that are going to come into existence based on the new advancements in SoC hardware.
Yeah, and so like the job of OS is really to abstract out all the hardware for you so that you can take advantage of all the unique hardware. And as I said earlier, what we really want to do is make sure that the unique value of each hardware also shines through in Windows, whether it's graphics cards or system on a chip or any of the hardware. And so we've got some cool demos of some ARM hardware here.
Yeah, ARM and SoC hardware combined. This is a Qualcomm ARM reference design. This is the one we showed at Computex. It's an 8660 Snapdragon. It's hooked up to this debugging system here that's measuring power really accurately. And what's going on this monitor is you can actually see the amount of power being used. It's very low. The system's not off. It's in a new power state called Connected Standby, which is a really low power idle state. You can see these little spikes that show up here. What's going on is Windows is coalescing all of the timer requests and all of the network requests, turning the radio on briefly, updating the apps, and then shutting the radio back down. So when I turn the system on, it turns on with one click, well, or two, depending on if you have demo gremlins. The system's on. You can see the power jumps right up. It's an instant on type scenario because it was never off. I can interact with the system here, and you can see the power kind of changes as we're rendering and we're drawing on the screen. And then when I go to turn it off, I click it. Immediately the power drops down. What's going on right there is the apps get a chance to pack up their data, and then it's shutting down, and then it immediately drops back to idle. That's the kind of system. Yeah.
I mean, so when we talk about fundamental performance, that's what we're talking about. We're actually taking the things that you experience like in phones, and we're bringing that to the PC architecture at the base kernel level.
And it's one of the things that all of these SoC systems will be able to do. If you go to the Understanding Connected Standby session, you'll see the same power demo running on the NVIDIA Tegra 3. We showed, like, it was 9 months ago at CES. It was the first time we showed ARM booting at all. And all it could do is like just boot Windows 8 up to the desktop and like one touch.
Yeah, I mean, it was just like a motherboard demo.
We've made a lot of progress since then. We've got everything running here. We've got fast graphics, the kinds of apps that Julie was running. They're all the exact same apps. I can go back to the beginning. I can launch another app.
So it sticks to your finger touch running on this prototype hardware.
Yeah, it's fast, it's performant. They're the same build of those apps running here, the same build of those apps running on this TI system. This is an OMAP system, a 4430. And for the first time, no one's seen this one yet. This is an Intel system. This is an Intel 32 nanometer Atom-based SoC development vehicle. I don't know if they're working on the name yet, but they're working on the power.
Yeah. I mean, it's so cool. Our partnership with Intel is great, and we're really excited to be able to show you that the progress that they're making on all of this kind of low-power work as well.
from SoC to high power systems. I have a couple high power systems here too. So that performance thing is at both ends of the spectrum, tiny systems and enthusiast systems. So this is an HP enthusiast system. It's called the Phoenix. It's going to be announced later this week, the full specs. Obviously, it's just announced now. But what I've got here is a USB 2.0 3.0 demo. So this has 2 drives inside of it. The one on top that I have open is USB 2, and the one on the bottom is USB 3. Now I'm going to copy a 1 gigabyte, I'm going to select and copy. Sorry, I've got to stay out of the way of the camera. A 1 gigabyte file here, and you can see the new progress indicator. And while that's copying, I'm going to grab a 1 gigabyte file from my USB 3 drive and show how much faster USB 3 copies. So that's like...
And we built this in. This is built in with a class driver, so you don't have to worry about finding all the drivers. We've done a lot of work to make sure that this works everywhere.
It does, and it works on all kinds of systems. I mean, this is a 3 terabyte drive that I put into that system. Windows 7, you could boot from up to a 2 terabyte drive. Windows 8, you can boot from a 256 terabyte drive, which, it's like science fiction or something.
Yeah, I got one of those in the back.
Well, you know, the reason that that's actually important is because while this drive seems enormous, it cost me less than $150 to buy and drop into that system. So these things are going to be coming soon. Another system that's a little bit extreme is my DX11 graphics system. I love this thing.
This is great. This is like ice over here.
Well, it's not like ice. It's like lava, actually, up top. Because what I have is I have 3 NVIDIA GTX 580s, DX11 graphics card, 3. They're linked together, they're running in SLI mode, hooked up to all the water cooling. But what this system is capable of doing on DX11 is turning about 700 watts of electricity into about 4.7 teraflops of computing power.
How many teraflops is that?
So it's like a woodchuck.
Yeah,
if you remember that giant Cray supercomputer, like the XPM or something?
Yeah, like with the big tower and the
nitrogen and stuff. It would take 2,500 of those supercomputers to do the same amount of processing you can offload to those graphics cards. It's actually...
And it's just Windows.
It's just Windows running on. But that sounds crazy, but it's actually useful. With the Direct Compute API, you can offload any kind of massively parallel calculation, scientific calculation, modeling, all to that. And
research labs are filled with machines like this.
Sure, and dorm rooms, because they're also awesome for the most unbelievably realistic and violent games you have ever seen. This is a technology demo here. This is a technology demo from Epic. It's using the Unreal Game Engine, which is all DX11 powered, and this camera doesn't do it justice at all. If you get up really close to that screen, you can not only see incredible levels of detailing, but the physics are all rendered in real time, and the whole rest of the world that's off camera is shown in a reflection in his eyes.
There's like smoke. The thing is unbelievable.
It really is. It really is amazing. You can see the wireframe for the tessellation. You can really understand the power of the graphics, but what's really